And now we're here. Welcome, everybody. Welcome, everybody. I'm here with Dr. Diana Benavides Prado. Is that correct pronunciation?
That's a perfect pronunciation. Yes.
Yeah. Thank you. We are at a bit of different background today.
Yeah.
Potentially one of the most
Attractive.
beautiful
Yeah.
background, at least on my podcast so far. We can clearly see where we are in Auckland, and we're at the Auckland University. It's such a nostalgic trip for me. For the viewers, I went to uni here and did all my undergraduate and postgraduate here, and now back at uni, but this time around at the comp sci department.
Yes.
Where you work, Diana?
I work here.
You work here, right?
Yeah.
As a senior lecturer. Is that
I'm
right?
currently a lecturer here. So I joined as a lecturer earlier, like a couple of months ago, actually. But I used to be a postdoc here before that, and I also did my PhD here. So yeah, my relation with this university has a lot of history.
Yeah, for sure. So you did PhD here too?
Yeah.
At the comp sci department, right?
At the comp sci department, yeah.
Yeah. And you did your PhD in machine learning and AI?
Yes, exactly.
Yeah. And what was that about?
So what I was doing was to study the way in which you can sequentially learn multiplicity of tasks using the same machine learning model.
Okay.
And that was, or is still sort of relevant when you have to collect data, for example, across multiple locations and use the same model to exploit that data for whatever tasks you are trying to train the model for. So that sort of area is called continual learning, because you are continually sort of refining the same machine learning model as you collect more data and observe more tasks. And there's a lot of technical challenges in that sort of topic, and one of the most relevant and the one that attracts more attention from the research community is the challenge of catastrophic forgetting, which is basically as you retrain the model with more data, you tend to forget what you learned before, unless you keep some data from the previous tasks around, which is sometimes difficult because of privacy reasons or because of lack of availability of that historic data. So, and the sort of interesting thing of that is that if we compare that to humans, for example, in the sense that we can learn continuously over our lifetime without forgetting in general, that makes a big difference between what these kinds of machine learning models can do as opposed to what humans can do in terms of learning.
Yeah.
So this problem of catastrophic forgetting happens a lot in those neural networks, especially models. But it doesn't seem to happen in humans, and that's sort of an area where machine learning hasn't figured out how to mimic humans in like more accurately. Yeah.
And the catastrophic forgetting, it doesn't happen naturally, right? Like because it happens as part of the machine learning model.
Yeah.
So surely is that something that's built in? Maybe like there's like a limited capacity to how much they can kind of contain in their model.
Yeah.
And when it exceeds it, they forget what they learned earlier.
Yeah, you're right, because these machine learning models, in particular deep neural networks, which is the technique that most people uses these days, they're limited in terms of the size of the network. So they are composed of a number of layers and parameters that you learn in each of those layers, but the size of that network and the number of layers and parameters depend on the task that you are training the model for. And it's usually limited because of, for example, computational constraints or in terms of storage constraints, that sort of thing. So if you are trying to use the same network, the same representation for a variety of tasks or a variety of data sets, for example, at some point you will get limitations on how to represent that variety using that single neural network.
Yeah, and like you said, that's something that as humans, because AI machine learning, at the end of the day, what the researchers are trying to do is really mimic the human brain, how we learn things, right? And it sounds like that's something that we have, something that we remember what we learned before, and by learning something new, we could all improve what we learned and how we performed in the task we learned previously. Taking learnings from the new task that we learned, right? And is that something that we're trying to do with the machine learning too?
Not exactly. As I said, the most relevant problem is that of catastrophic forgetting, because in the neural network space we haven't managed to resolve it. Now, the thing that you mentioned in terms of, for example, improving the existing knowledge as the network observes examples of other tasks in the future, that's sort of beyond that problem of catastrophic forgetting.
So that's the kind of first problem to tackle first.
Yeah.
And then
But that second one is actually the ideal and one of the most interesting areas that I keep looking at. But it's even more challenging than the problem of catastrophic forgetting. I guess as long as we don't manage to resolve catastrophic forgetting, it will be much more difficult to encourage that possibility of improving the machine learning model with new incoming tasks. But that's definitely interesting.
Yeah, for sure. And with the catastrophic forgetting, the difficulty of solving that, is that case by case? Because I imagine, like, say a machine learns to recognize an item. Say it learns to recognize a cup, for example, and so that's trained to do that, and then you try to train that machine learning model to recognize maybe like a mug or something. I feel like that would be maybe with that, maybe it's less of an issue for catastrophic forgetting because it's mugs and cups looking similar, whereas you're training that model to recognize like a person, mug and cup and a person looking completely different.
Yeah.
Maybe it's more of an issue. So maybe that issue is harder to solve it then, or is that a factor at all or not?
You have been doing some reading, I can see.
I've just been thinking about
because that's one of the main considerations in this area. Like, you're right. Like, if the machine learning model has to learn things that are very different to each other, then it's going to be more difficult that knowledge, there is no interference of those tasks, right? And there is no forgetting. But if those tasks are more related to each other, more similar in terms of their data and how the features that you extract from that data are represented, then it's going to be less of an issue. So the concept of task relatedness is also a very important concept in this area. And there's been some work in trying to measure that, but at the same time, it's very difficult to measure that, especially for the kinds of data that we use today, like image data or text data, which is very high dimensional. So measuring like some concept of similarity in examples in those types of data is very challenging. So there's no solution for that either, but it's definitely a consideration in the field of learning continually. Yeah.
And these days, I'm sure you know that like the AI and machine learning is becoming more and more relevant to everyday life, right? And therefore I feel like, correct me if I'm wrong, but I feel like there is more demand for each model to be a bit more robust and a bit more versatile. It can do not only one thing, but maybe several things. Like it's not good enough that it can recognize if an object is a cup or not, but it should recognize what that object is. So do you see that as the time goes on, catastrophic forgetting, the issue of catastrophic forgetting becoming more and more relevant these days?
It depends on the point of view.
Okay.
Because you're right. Like these days with the advent of large language models, for example, where you as a developer or as a researcher or someone who's just interested in machine learning in general can access those very large models that have been trained on very large data sets like the data on the web. That gives you a lot of information in a single model that you can potentially simply extend to your particular application. So a problem of catastrophic forgetting on those large language models is less of an issue because of the availability of data that those models originally had. From my point of view, I think on this every single day. So from my point of view, this access to those very powerful models are sort of enabling like many new applications that we didn't previously have, because we had to train like models from scratch for our particular application. So going back to a topic of catastrophic forgetting, in that sense, it's not that much of an issue, right? Because we don't have this problem of learning continually, because we have a lot of knowledge represented in a model which is available to us. And we just need to add whatever is necessary on top of that for our particular application.
Right.
That's not going to work for every single case. So for those cases where you, for some reason, you cannot access or you cannot use those pre-trained large language models, then catastrophic forgetting continues to be the same problem. When you have applications where you require like observing data continually and training your model continually because of the specific application. So in that sense, it's still an issue. In the sense of large language models, is not that of an issue. But at the same time, talking a little bit more about those, leaving catastrophic forgetting on a side and talking a little bit more about these current techniques around large language models. I think that even with the availability of those models, there's still a lot of work for those to be applicable to a lot of different problems, because they're not 100% accurate, or because you don't know what data exactly they have been trained with. Like in general, you know that they have been trained on large amounts of data from the web, but you don't know how well represented is the data from a particular application domain, for example. It depends on what's available on the web. So it means that those large models are not solving every single problem that you can encounter when you try to use machine learning for some particular application.
For sure. And you've been in this area of study for several years now.
Yeah.
And is the main application that you're looking at, is that large language model? Is that the main application that you've been looking at?
Not really. So I work a lot on continual learning because of what I just said, that not every problem can be solved with the access to these large language models and adding some model or knowledge on top of them. So I'm still quite active in the area of continual learning and the old problem of catastrophic forgetting, but also a problem of trying to refine the existing knowledge as you learn an increasing number of tasks. So that's still interesting. And I'm also working, like I guess everyone else in this field, on the looking more deeply into the behavior of large language models, looking at what sort of applications can be actually those models be helpful for, looking what's missing in those models, looking at things like making those models more, or the use of those models more feasible for certain applications, like in some way the fact that accessing those models is not that computationally expensive. So I keep an eye on the developments in areas like democratizing AI and how can everyone have the same sort of rights to access those models, which are actually repositories of a very important piece of knowledge, right? Because it's everything that we have put on the web.
For sure, yeah.
Up to some point in time. So, yeah.
Do you mean like ChatGPT as an example? They would be like the main one that would.
Yeah,
be,
so I've been
right?
using the technical term,
Yeah.
large language models, which is the kinds of model like ChatGPT.
Yeah.
And so ChatGPT was developed by OpenAI, a company in San Francisco, if I'm not mistaken. I'm maybe saying the wrong thing, but somewhere in the US. And there's many other versions of those so-called large language models similar to ChatGPT, developed by Meta or by Google, by Microsoft. I mean, there's a lot of activity from the high-tech companies in developing those kinds of models. Yeah.
Yeah. Would ChatGPT, the model used for ChatGPT, they would suffer a lot from catastrophic forgetting as well, right? It's like you're trained with this bunch of set of data, and as more data come in, on the internet every day.
Yeah, that's true.
Yeah, and so much data already there, but so much data always coming in, and I feel like it's gonna be.
I think it's a phenomenon that may be similar to catastrophic forgetting,
right.
But it's more like around not representing well new knowledge, right?
How do you mean? Sorry.
Like for example, ChatGPT has been trained with data on the web up to 2021.
Right.
So whatever you find on the web which is beyond 2021 is now in that knowledge base called ChatGPT.
Yeah.
So whatever new information you have is not represented. So it's not catastrophic forgetting.
Right.
It's not learning new things. Right?
Yeah.
Yeah.
It's catastrophic lack of learning in case of ChatGPT.
Yes. Yeah.
Yeah.
It can be as catastrophic as that new knowledge does not fit like whatever you have represented, right? So if it differs too much from what you observe before 2021 in the training data, then it's going to be completely new knowledge. So it's catastrophic in that sense.
Yeah. And like we briefly said about one of your research area being continuous learning system.
Mm-hmm.
And you published a paper in 2020 on continuous learning system, right?
I say that you were doing some
doing some research, Diana, and that was with support vector machine. And and now you said the kind of the state of the art for that is neural network. Is that right? Yeah.
Deep neural networks.
Deep neural networks, right? Can you tell us about your paper in 2020 and kind of the evolution of that to where we are now with the research?
Yes. Yeah, I will try and explain myself in the best way possible. So that paper was, it was around continual learning of a set of support vector machine models. And
sorry to interrupt. Could you explain what the support vector machine is?
Okay.
For those who's less knowledgeable on the modeling side a little bit.
So support vector machines is a very classic technique in the machine learning field. That was very popular in the early 2000s before deep neural networks became popular. But it was not invented in the early 2000s. It was invented much earlier than that.
Okay.
Like I should know this, but in the 70s, 80s,
Whoa,
something like that.
That's quite back.
And the beauty of that technique was that it had like a very strong theoretical component of it. Because, like machine learning is an area that was born from the field of statistical learning. So the earlier techniques in machine learning were very well theoretically grounded. And one of those techniques is support vector machines. And it was quite successful in the early 2000s for tasks like classifying images or text mining tasks. And the idea of the technique, which I said was very well defined in theoretical terms, was that you would sort of learn what is called a hyperplane that would fit your data from your particular application better. And like any other machine learning technique, you will run the process of fitting that data through that hyperplane iteratively in such a way that you minimize something that you call the loss function. Sorry if I'm being too technical here, but that's very general to like machine learning techniques. You have a function, you have some data, and then you try to minimize the loss of that function using the training data so that whatever thing you learn with your model has the least error on that data, depending on the type of tasks you have, like classification or regression or whatever.
So they will be saying basically decide telling the model when you do, I guess, defining what a good job is and rewarding the model when they do a good job and not rewarding it when it doesn't. Yeah,
so that's one way of that's the way of doing machine learning in what is called supervised learning, where you have some ground truth that you can observe and you can evaluate against. There are other types of machine learning that are not relevant, I guess, to this discussion, but you can also have like reinforcement learning, where the concept is more around an agent that plays with an environment and gets some reward, and by getting that reward, it learns which actions are the best actions to perform. And there's also plenty of techniques for that sort of problem. And lately, there is self-supervised learning, where you don't actually need that ground truth, but you use the data to build that ground truth and to train your model.
Yeah.
But anyways, SBM was in the group of supervised learning techniques. And as I say, it was very popular and very well theoretically grounded. And the thing that I was trying to do with SBMs was, as I said, learning a sequence of SBM models, one for each task, classification task. And in that paper, I use image classification tasks, which was like sort of the standard sort of data to use in continual learning at that time. And what I was trying to do, so I wasn't necessarily trying to solve the catastrophic forgetting problem, because I found it very not easy, but I wanted to go beyond that.
Right.
So I actually ended up trying to find a way to do exactly what you say a while ago, which is around improving the existing knowledge while you learn more tasks sequentially. So in that paper, I talked about 2 problems that you could tackle in order to improve your machine learning continual system. So one of the problems was the problem of forward transfer, and the second problem was the problem of backward transfer. And I'm going to explain each of those.
Yes, please.
So forward transfer is basically this ability of learning new things with more accuracy or faster when you learn those new things using help of things that you have learned before. So like happens in humans, right? So for example, in our case, this is the example I always use. When we're learning to drive a car, we need to use some skills, right? And because I don't know how old are we when we learn to drive a car, but not 5 years old, definitely. But maybe at 5 years old, we learn to ride a tricycle or something like that, and later on a bicycle. So we actually learn to or train some particular skills that could be relevant for learning to drive a car, right? So the problem of forward transfer is how to use that knowledge that we acquire when we were learning to ride the bike to learning drive a car faster, or maybe with better accuracy, which means, for example, we are better drivers. So that's the problem of forward transfer, like learning new things better using previous things. So that was one of the things that I was trying to do with the SVMs, learning a new SVM using previous ones as an input. And that's in general the problem of transfer learning as an area in machine learning. So basically you have one model, you need to train a second model, and maybe in the second model you don't have a lot of data to train it. So what you try to do is to inject some of the knowledge of the first model into the second, so you can learn better or faster. Again, it depends on how related those 2 things are.
Might be completely irrelevant and doesn't help.
Exactly.
Right?
And it's a lot of going back to a large language model and ChatGPT discussion. It's a lot of what you see now. So you have a model which is very knowledgeable, right? It has a lot of things to it because it has been trained on very rich data set from the web. And then you try to learn something on top of it by sort of injecting this knowledge, right? In that second thing that you're trying to learn. So that's the problem of transfer learning or forward transfer that I called in that paper.
I feel like we're almost part of that model somehow, because, say, for example, you're coding up a machine learning model, like brand new machine learning model, and you don't know you forget some syntax of like Python, and you ask ChatGPT, and ChatGPT spits out an answer, and you copy and paste that. In some way, that's like a forward transfer, right?
True. I mean, that's a very good point. Yeah, that definitely can happen between humans and models, or AI agents, or whatever you want to call them. I mean, we can have 2 ways, right? Transfer, where the human actually gets something out of the model as knowledge. And also, hopefully, I mean, we don't have that kind of thing right now, but humans inject something into a model. We sort of have that thing in GPT-4, which is the model behind ChatGPT, where they actually use humans to give feedback on some of the outputs of the model in order to make sure or to minimize the risk that the model would give answers that were inappropriate, for example, like, I don't know, related to hate or to racism or those kinds of bad things that you can actually see on the web. So that was, some sort of human AI transfer. So that's one one way of looking at that. Yeah.
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 Oh, cool. I think the scary thing would be when we don't have to do that. You know, like in my example, for example, I'm, querying a question to ChatGPT,
Yeah.
and it spits out an answer, and I'm copying and pasting that, and to make another model. And when we, we'll reach up one point where we don't have to do that, and maybe like a big AI system will make its own query and develop a model on its own.
I mean, that's a possibility.
Yeah.
Because the most progress there is in this area, the most powerful those models are going to be. Yeah, I mean, like in the old days of machine learning, you needed to have very specific data and very specific techniques and build very specific models. Now we are in a time where you can actually use one big model to generalize to a lot of tasks.
Yeah.
So it's definitely sort of covering more of the problems that we humans could solve. Yes, so it's definitely a possibility.
I think at that point, the AI would have reached a point where it could just improve its own model, right? Is that a possibility? Just continuously getting smarter.
From my personal point of view, yes.
Yeah.
It's not an immediate possibility, and maybe it's not a short-term possibility, but I don't see any technical constraint for that not to happen.
I'm aware I'm holding up the discussion on the forward transfer.
Forward transfer,
yeah,
because transfer is so general and is so used these days. It's
so interesting. It's such an interesting topic, especially these days even with ChatGPT, and like I'm sure you've seen like the DALL-E model, and a lot of people one of the issues now is that people are worried that are the artists' jobs being taken away, are the writers' jobs being taken away, and so it's a definitely an interesting topic these days for sure.
Yeah, I mean there's a lot of discussion, and I guess there will be discussion for a while because it's true. I mean, there's a lot of tasks that you can automate, right, or help automate with these new techniques. But on the other hand, I'm not sure. I mean, are we humans replaceable? I don't know. I mean, the last time I was in this event, the Auckland Writers Festival, and there was a panel discussion on creative writing and AI. And one of the panelists, she gave an example of one of her previous writings. So she had the example of her creative writing, and the creative writing created by ChatGPT.
Yeah.
And you could actually see difference. So
Right.
the ChatGPT one was not creative at all. Because of course, like AI models are not creative, right?
Yeah.
It depends again on what kind of data they've been trained for. But as I said, as we encounter more tasks that those techniques cannot currently do, there will always be research that will try to solve those tasks.
Yeah.
Because that's what research and research progress is to be about, right? So we will definitely be covering more things that we don't cover now. But to be honest, from my point of view, I don't know to what extent.
You don't.
Yeah, I don't know. Like, I predict that a lot of tasks that humans do at some point can be automated by these models. But I don't know which tasks or how long is that going to take, and how many of those tasks are actually, how big is that set from the set of possible tasks that humans can perform. I think humans, we are still useful.
I think so. I would like to think so. There are a lot of people believing in that because especially with like Tesla. Is it Tesla or Elon Musk's one of his companies researching in like neural links and things like that?
Uh-huh.
A lot of people are saying that we are probably the last generation that don't have any augments. Yeah. And maybe in 10 years, most people have ChatGPT installed in their brain, and
that's very futurist. I mean, yeah, there's a lot of things that people say, but using the example of Neuralink, is very interesting, like what they're doing, in the sense that by trying to recover some of those connections that humans lose, right, in their brain, like neuronal connections. If they manage to do that, then they can help solve a lot of issues for people suffering diseases related to a brain, right?
Yeah,
so
be
that
so
could
good.
be a big success. So it depends on the point of view.
Yeah, that's true.
Because if that's one of the outcomes of that sort of technology, I would be happy to sign on them, because it can help many people. But it hasn't happened so far, right?
I think there was some research and some successes to it. I remember there was hearing briefly about, was it soon to be, or maybe there was like a research going on with like eyes to restore someone's eyesight. So I think, I guess depending on how you define eyesight, but it basically, it projects image into your brain rather than fixing your eyes. You basically make it so that like it projects image to your brain, and that's how people see it. And I guess there are other research, like if you maybe lose like feeling in your legs or something, and those kind of research is ongoing. But there would be ideal kind of like a good part of this coming off this research.
I guess like with any technology, it depends on how we use it.
For sure.
Right? So if we use it for a good purpose, then it makes a lot of sense. Now, if we start implanting chips on people's brain just to control people, that's not a good outcome. So, yeah.
I really like listening to your point of view, Diana, because I feel like you're optimistic about the positives that this can bring. Is that fair to say?
Yeah. I mean, I'm optimistic. I mean, I see the opportunity this can bring. But it's, like I said right before, it's up to us, right? What do we decide to do? I mean, the development of these technologies and the research on these uses of AI and potential problems that it can help solve is not going to stop, right? So, because there's too many researchers and there's a lot of people wanting to develop technology and a lot of technology companies wanting to make progress. So as long as we manage to use that in a good way, then that will be a good... I mean, I expect that humans, we can do that, right?
Fingers crossed.
Yeah,
I hope so. Cool. So that's the
that
first
was
part, the forward transfer.
Yeah, so backward transfer, I guess it won't be too long.
Sounds less scarier, that one.
I don't know. In simple terms, it's just the opposite. So you have a new task, you have a set of previous things that you have learned. So you try and refine whatever you learned before from that new task.
Right.
So that's the backward to it. And it's in general a more difficult problem. It's not that popular. I mean, not many people has tried to solve that because it's difficult. Because then you need to decide like which parts of this new knowledge are which parts of the old knowledge are subject to change, right? You should actually update in order to improve your overall performance. So it's sort of more difficult problem.
Yeah.
And it's not that, I mean, there's been some research around the fact that it actually happens in humans.
Okay.
Like there's a few papers on that actually show that, for example, in learning languages, you sort of end up refining. I think it was between Chinese and Cantonese. I'm not sure. I have to look at the papers.
Yeah.
But when you learn a new language, you end up improving some of the things that you learned in a previous language. And there was another example on learning mathematics. Like learning to solve linear functions and then learning to solve quadratic functions. So there were some pieces of knowledge that you could improve in the linear case when you were learning quadratic terms. And there were like a few papers in that regard, but there's not too many papers on that.
Right.
But I actually like that problem. So
okay.
Because of what I say, that it represented like going a little bit beyond the traditional forward transfer and the traditional catastrophic forgetting, more to can we actually improve what we know so far, which from a common sense point of view seems to be a thing that happens in humans, although there is not much research in that regard. Yeah, so I said backward transfer was going to be shorter. Yeah.
Yeah, true. And where are those, in terms of research development and where the research are at, is I think we briefly mentioned that deep neural network is kind of the state of the art thing to do with those.
Yeah. So I did that with SBM, success.
Yes.
Just to mention, one of the things what I did that with SBM was because of what I mentioned in terms that technique is very well understood theoretically speaking. So you could actually do theoretical analysis of forward and backward transfer, which is what I did. In deep neural networks, that's not very much the case. So deep neural networks are very successful, have been very successful in the past 10 years or so, and now even more with these large models. But there's a lot of work in terms of understanding what's going on inside those network layers and very deep layers. But there's not like a common understanding of how that technique actually works, apart from the fact that you have some input data, you run it through a certain number of layers, which is usually very large, and you sort of optimize, again, a loss function that tells you a signal on where you're doing good or bad, and then you change the weights of that network in such a way that you minimize that loss function. So that's in practice, but in theory, is not as well understood as the SVM, for example.
Right.
So in terms of forward and backward transfer, in deep neural networks, forward transfer has been more popular, much more popular. Like the example I was giving with the large language models. That's forward transfer. Yeah. So a lot of transfer learning work is now, transfer learning equals forward transfer. So a lot of transfer learning work is now in deep neural networks. The problem of backward transfer is not, again, that popular at all. There's been very few papers in that sort of problem with deep neural networks. One of them was last year. There's like up to 5 papers or something,
really?
like a very, very extremely.
And one of them is your paper from 2020.
That was SBMs.
Yeah,
So-
with the deep neural network.
Yeah.
Okay.
Yeah.
So sounds like a bit of a gap in the market, yeah. Like
That's what I'm trying to.
yeah.
Yeah. So I'm definitely quite active working on that.
So-
Since 2020, then I moved into a deep neural network space. Not only because that's what everyone else is doing, but also because I mean, that technique beats SVMs in in all of the most challenging tasks now. So it makes sense, right? So I've been working a lot on actually trying to implement the backward transfer mechanism in deep neural networks. So I'm still working on that, but I cannot tell yet that I have any sort of actual result. But yeah, I continuously have ideas, trying them out. They don't work, and that's what research is supposed to be.
Yeah, just like your motto, it's a continuous learning journey, you know?
Exactly.
Continual
like
learning.
humans.
Like humans, yeah. So is that your main focus of research now?
Yeah.
Backward transfer
that is.
using deep neural
And that's
network.
why I study large language models, because everything is converging to large language models. So now my problem is, how can we use those architectures associated with large language models to encourage the idea of backward transfer? That's basically what I'm at this very specific moment, like today, working on.
Yeah. So that will be your daily research, right? Whenever you have time away from like lecturing and teaching.
Yeah. Yeah.
Do you, kind of a separate topic, this one, but you got into one of the motivation of studying the PhD, especially in computer science, was because of your undergraduate lecturer who had a PhD in computer science, right?
Oh, okay.
Is that fair to say? Is that
yeah,
correct?
I think I mentioned that at some point.
Yeah.
In another podcast, right?
Yeah, Let's Talk. Oh, it's Nikki's. I heard it on Nikki's podcast.
Yeah.
Let's Talk Robotics.
Yeah.
Shout out to Nikki, Dr. Nikki Rosso. I might be butchering her last name, but I really enjoyed that episode.
Yeah, it was a short one, much shorter than this one.
Yeah, much shorter than this one, but well, they covered a lot. You guys covered a lot, even.
Yeah.
Even just
that. From my ancient history back in Colombia.
So you're an undergraduate student at that point, and then you had a lecturer who had a PhD
it was like what year was that? 2006, something like that. Like, how many years is that? How many years ago?
Like
almost 20.
Almost 20. Yeah, 17 years ago.
Yeah. I mean, it's a very simple story, I guess. He was teaching databases and transactional systems course. I was always really interested in whatever was related to data. Not just data mining, but data, like organizing data or querying data or whatever.
Where does it come from?
I have no idea.
Is that right?
No. I have no idea.
So you didn't see like a cool video of like a robot or... Yeah.
No.
Okay.
I always like maths and that sort of thing.
Cool. It's always a good start. But
or maybe organizing things. I like that.
Do you like that?
Maybe that's what it comes from. I don't know.
Yeah. But it's is there something that... Because when I was in high school, I didn't really know about... I mean, obviously knew like I studied math, I studied physics and so on. But I didn't know like data was like a separate issue.
Me neither.
Okay.
So in high school, I really liked algorithms, like designing, like the way in my times, the way in which they would teach you about like computational reasoning was using flow diagrams.
What was flow diagrams?
I don't know if I'm using the right term. I think it should be called flow diagrams. So you have a start and an end, and then you have a series of steps, and there's some nomenclature, right?
Right.
So if you have, for example, something that you need to assign on, like decide on, like a conditional or something like that, then you use some particular figure. Or if you have a process, you use it. So it's basically that thing of organizing the step by step. I really like that.
It's like coding, right?
It's like coding.
Yeah.
Because that's like I remember in my undergrad, my first programming course, which was not Python or anything like that, but C.
See, whoa, whoa, there was a deep dive straight away.
C.
Yeah.
So a lecturer would ask you to, in the exam, he would ask you, it was a he, so he would ask you to write the code on a piece of paper.
Like write it down with
Yeah.
your, yeah.
And also to write this diagram that I'm talking about. So you have the step by step, and you say, oh, in this step I need to define a variable that
Right.
has certain values, so that will end up in terms of code in this line of code. But then you need to have that algorithm step by step. So yeah, good point. I really like that in high school. That way of looking at things step by step. And
Like a
solving
logical
problems.
mindset.
Yeah, I think
Yeah.
so. So maybe that's the reason. Good point.
Yeah. But I feel like even then, like a data is like a almost different section, you know, like from coding, you could get into
Yeah.
mathematics,
That's
could
true.
get into even computer science, but you know, not necessarily nothing to do with data, maybe.
Yeah, so maybe, you're
Yeah.
right. That's the reason for computer science. For data, maybe it was this lecturer.
True.
Maybe, yeah. Yeah, I think I mean, I really like that class. I really like writing code in SQL and
Cool.
and doing like predicate calculus and that sort of thing.
Yeah.
So, and I actually admire the guy. I mean, he had a PhD. Oh.
That's cool.
So yeah, like I said in your podcast, yeah, that was the reason. It's very simple reason.
And like you mentioned in Nikki's podcast too, it was interesting that his PhD was in computer science.
Yeah.
And I was gonna ask you, do you think, is there a significance you doing machine learning in the computer science department compared to, say, if you were in mathematics or statistics, or even maybe psychology, maybe?
I guess in computer science, you tend to think on the computational issues of things.
Yeah.
That maybe you don't think in mathematics and statistics. But on the other hand, I mean, I'm pretty sure that when you do machine learning from the pure point of view of maths or stats, there's a lot of other things that you look at that computer scientists don't look at. So, but for computer scientists, I can tell that we're always worried about the efficiency of things, right? Because computation is supposed to be limited. I mean, it's no longer the case these days. You have GPUs, and as long as you have money, you can buy GPUs and process a lot of things. But like our mindset is around designing algorithms that are efficient. That's what we are taught through our education, I guess, to some extent. So, but I was not originally a computer scientist. I studied systems engineering.
Okay, so that's a branch of engineering, I'm guessing?
Is the closest thing that we have to computer science in Colombia, because funny thing, we don't have, or we didn't used to have a computer science degree in Colombia, in none of the universities.
Really?
I don't know how many universities there are, but there are too many.
Right. There are too many?
In Colombia, yeah, there's a lot of universities.
Oh.
Yeah. It's a country of 50 million people, so...
Right, yeah.
I should know a number of universities. But anyways, so yeah, we didn't have computer science degrees. I guess the first computer science degree was established no longer than 5-7 years ago.
Oh, wow.
And in one university, the National University country.
Whoa.
Yeah. But usually, if you wanted to do something around computational sciences, then you would study systems engineering, which is computational thinking from the point of view of engineering, I guess. I mean, you still learn programming, you still learn some stats, you still learn like all of the algebra and calculus, but you learn other things around engineering as well, I guess. like operating systems, but that's
Yeah.
also part of computer science.
True.
It's very similar to computer
Yeah,
science.
sounds like it.
Yeah,
I was
but it's not called computer science. It's systems
System.
engineering, and it's usually part of the faculty of engineering programs, not faculties of science.
True.
Like in New Zealand, in other countries. Yeah.
I was thinking with your lecturer, if he's still active, you could collaborate with him.
Yeah, I barely remember his name. He's probably not active anymore. He was quite old at the time.
Right.
Yeah, and I barely remember his name. Yeah. At some point, I was looking at his email address. I don't even have his email address. So yeah, he was sort of retiring at the time. So yeah.
Yeah, and before this, your position here as lecturer in the department here, your work school at the
School of Computer Science.
School of Computer. Is it different to department? Oh.
I think it's bigger.
Is that right?
It used to be a department, and now it's a school.
Okay, my bad.
Sounds more important.
Yeah. My bad. School of Computer Science.
I'm just kidding.
Yeah. Your I saw one of your talks on Allegheny Family Screening Tool project.
Oh, okay.
Yeah. And
you have so much background.
a little bit, I just there's a lot of research that you put out there. So thank you for that first. It's awesome to see it.
Yeah.
And from there already you're working on like machine learning projects from that position, right?
Yeah, so I have worked in actual machine learning tools that actual people use.
Yeah.
So Allegheny Family Screening Tool is the main example. So it was not very simple, but a small machine learning model that tried to help decision makers to prioritize calls of people reporting child maltreatment. And we implemented that tool in Allegheny County in US. As I said, like the model itself was is very simple. We did a lot of work around feature engineering, like figuring out what the columns of the input data should be and what sort of data sources to include, like a lot of work in terms of understanding the domain and understanding the data and shaping the data in such a way that was useful for the model. Not much work on the actual model, like on the actual technique. But of course, the outcome was really good because we implemented that in 2016 in this county I mentioned, and they are still using it.
Yeah. So to this day. Yeah.
So it's been 7 years. Yeah.
Well, that just it's withstood the test of time, right? It's like it obviously works. It's a good model.
Yeah.
Yeah.
And it's received a lot of attention because I guess, that problem of prioritizing those calls is very controversial sort of problem because then, something really bad can happen to a child that is not
for sure
approached by the social services. So in that sense, the model is not 100% accurate because no model is, but I think we managed to have a good combination between what the model could inform people and what decision makers could actually do with that information. So it helped them process a lot of features in a single number, a score, that could help them, along with other factors that they usually look at, could help them to evaluate those calls and to prioritize them for investigation. Yeah. So yeah.
And you have a lot of experience with this machine learning models, and I think we mentioned it earlier that at the end of the day they're just trying to replicate human brain, how we learn things, right? Yeah. Do you think a lot about and this is me coming from the background that you're into Stoicism and the Marcus Aurelius meditations.
Yeah, I'm not that sure now. But
Do you think much about kind of at that level where it's not just a kind of computational problem, but it's, I don't know, maybe even at some point maybe it becomes like a philosophical problem on how we learn things. I think creativity would be a good example where, like we were saying, that ChatGPT is not really creating, it's based on like the data that it was being trained in. But you could say something similar about us, right? Maybe we're not being creative, maybe we're just basing on things we see around.
yeah.
Yeah.
Yeah, we don't create things from scratch, right? We always steal from our
Inspired is
yeah. I don't know, in my optimistic point of view, like you said before, yeah, I guess these machine learning models can be and actually are a big help for humans. So it's just like, of course, they're not actual humans, but they have a lot of knowledge represented in a different way and acquired in a different way than our knowledge, which we acquire through experience and different sorts of types of processing. But I guess the point is how you use those models and that knowledge for the benefit of humans. I guess that's could be a philosophical question.
Right.
It's not like whether they're human or not, or whether they're better than us or not. It's how can we use them for our benefit as individuals and as a society. Like the example I was giving with Neuralink. If we can use those developments for the benefit of people who's actually suffering from some particular illnesses, that would be, that would make such a big difference to those people and their families.
Yes.
So, yeah.
How much research is there around like AI ethics? And
A lot.
Is there a lot?
Yeah.
Oh, that's so good to hear.
I'm not in that field because I'm not an expert in ethics, so
Yeah. So would that be more philosophy?
yeah,
field?
there's a lot of AI these days has a lot of interdisciplinary work of computer scientists with philosophers, with psychologists, with social scientists, because it's apart from the technical bit to it, is something that we are already interacting with, right? So there's a lot of things to learn from that interaction. There's a lot of things that psychologists study from humans. There's a lot of things that computer scientists study for machine learning models. But in that intersection, there's a lot of things that we can actually learn and improve. And so AI ethics is definitely a topic that many people is working on today, and not just computer scientists or mathematicians or statisticians, but people in our fields.
Yeah, and I guess like the availability too, maybe making that available for not just a certain group of people, for everyone to kind of thing would be pretty important as it goes on. Yeah. Otherwise, some people that know how to use it probably excel. Someone with ChatGPT versus someone without ChatGPT. Could be a big difference.
So there's also people working on democratizing AI. Some of them from the point of view of researchers having access to the same thing, so they can contribute to development of those things fairly, but also in terms of the access of ordinary people like us to those kinds of technologies.
Cool.
I guess it's the same that happened with our technologies like the internet, right? I guess at some point there were concerns and discussions and ethical issues around how fair is for one person in New Zealand to have access to also New Zealand, sometimes the internet is not that good, but to have access to internet as opposed to someone who lives in a remote village in some country in South America, for example. I don't know, just not to be biased. Is that fair, right?
Yeah.
Because the access to information and knowledge for some people could make a difference to people's opportunities and later development in life. So it's the same with AI, I guess. So yeah, there's a lot of concern. There's a lot of discussion around regulation of AI. So what things should we allow AI to be used for, and what things not to use for? So yeah, it's not my area, but yeah. So far, I guess also there's no agreement on that discussion.
Yeah.
Like, yeah.
Very interesting topic.
Yeah, it's very interesting. Yeah.
And it will be more and more relevant, as AI becomes more and more part of our lives going forward.
Yeah, so I guess at some point, definitely we will have a specific regulation, actual regulation for. I mean, I guess there's some pieces of regulation already in US and in the European Union, I think. Like GDPR in the European Union was a piece of regulation in terms of the privacy of data.
Yeah.
And, for example, the right to an explanation, thing that people should have the right to an explanation on something that has affected them that is actually the result of running a machine learning model, for example. So, and GDPR has been around for a few years now. So there's definitely a lot of work on that. A lot of that is not new. It's like, it's been sort of been developing along with the development of these AI technologies.
Oh, I'm happy to hear that. That's been ongoing on the background.
Yeah. But as I said, there's no agreement, right?
Yeah.
And there's not like a checklist right now where you can say, oh, this is a safe use of AI and this is not a safe use, and everyone agrees on that, or this is ethical and this is not ethical. And yeah, there's a lot of discussion, pieces of regulation coming out, evaluation of risks, people who's extremely concerned, people who's not that concerned, even like researchers. There's some groups that are writing letters signed by 1,000 researchers expressing their concerns around the risks of AI for humanity. But there's another group that signs another letter that says that it's not that actually the end of the war. And so there's a lot of points of views around how risky AI is for humanity in general.
Elon Musk is big on saying that we are not being careful enough with the evolution of AI.
Yeah, so he signed that first letter. Yeah, I mean.
And I feel like he will know some things that we don't know too.
Probably. Back to a point, it depends on what we use that technology for. Because I remember the first of these letters that came out, it was, we should ban any further development of AI from now on.
Wow.
Everyone should stop.
Yeah.
Like turn off their servers, their GPUs.
The school of Kansai
and stop doing that.
Yeah.
I think they say it like for 6 months until there is some more clear regulation on that. Of course, it just doesn't make sense because, I mean, there's so many companies and researchers working in this area that it's not going to. How can you control that?
That's not very feasible.
Yeah, exactly. Like. Yeah. So then later on was another letter, and it was less tragic in that sense. But yeah.
Have you heard of Michio Kaku?
Who?
Michio Kaku. He's a physicist.
No.
Oh, he's a genius physicist. I think he built particle collider in his basement when he was like 15 or 16 or something like that. And he's recently written a book on quantum computing. And he says that they will change the world, the way we compute things, and how much more powerful the computers will be, and therefore that it will be so significant, so that it will be even more significant than when the internet came in. So the impact of the internet that has. So I was wondering, if you have heard of him and had any thoughts. So, because with these training models, one of the things is the computational limitations. Often, right?
But again, there's a bunch of people also working on making this training of these large models more computationally efficient. And some of them are actually using quantization for that. So there's also development in that. Like I said, I mean, there's a set of limitations to what those things can do now, and there's always a set of people, which is quite a large set, working on those limitations to try and improve things. So the computational requirements of training those models is definitely something that in the computer science space and the physics space as well, I guess, and mathematicians and are very likely working on.
Thank you so much for your time today, Diana, and for your insight. And it's been awesome talking to you. And like I said, I feel like you have an optimistic outlook to the future. So it's always good listening, hearing you and talking to you.
We can catch up in a few years and see
see how it is. Right, sounds good. Before I go, I do have a quick set of questions. I have a new segment called Quick Fire Question segment.
Oh my God.
It's gonna be like, question and then boom, answer, question, answer. Before that, I do have because I'm a data scientist myself, and I'm kind of surrounded by people that are interested in these machine learning AI models. Do you have any advice for them? Maybe in terms of the programming languages they should know, or the research they could look into, or anything like that?
From the top of my head, programming language Python.
Python, yeah. Is it your go-to language? Cool.
What else? Keeping track of large language models development, or generative AI, which is the most common name. So generative AI, and for learning things on those areas, there's a lot of resources online. I've even taken Coursera courses on that, and they're quite useful because they give you an overview of those topics, and then you can go into details on your own. Those online courses. There's this framework called Hugging Faces that has a lot of those generative large language models available for use, and a lot of data sets that you can play with. In AI, keeping an eye on the development of those large language models area. What else? Let me remember. I don't know. For example, I use social networks like Twitter and LinkedIn to sort of get technical updates on things. So if you follow the right people, that's a good way to find new information or new advancements in this field. So I think that's pretty much it.
Speaking of social network, is there something is there a page that you like to plug at all? Is LinkedIn a good place to follow you if if the listeners have any questions? Or
I'm quite active on LinkedIn.
So that would be the best one to contact you. Awesome, cool. Thanks for that, Diana. So here are the quick fire questions. Are you ready?
Let's say yes, but I'm not sure.
Well, that was the first question, so good.
Okay.
Yeah. Question 2. What is your favorite IDE?
My favorite IDE is Anaconda.
Okay. And I think we maybe a bit of a spoiler there before, but your favorite programming language?
Python.
Python. Do you have a favorite programmer or maybe someone in the AI ML space that you look up to at all?
Like a person.
Yeah.
Not necessarily programmer, but I follow this magazine by someone called Sebastian Rashka.
Okay.
He has a website with his name, and he publishes quite interesting, not very long articles on recent developments on AI.
Oh, cool.
And some of them link to research papers, some of them link to programming tools or frameworks. So it's very interesting. And it's a very good way of keeping track of the field and things you can use in a very quick way.
And what's his name?
Sebastian Rashka.
Rashka.
Yeah.
And how do you spell?
Rashka.
Oh, definitely check that out.
Yeah.
Do you have a favorite series or movies?
Wow, that's a difficult question.
Yeah. Maybe one answer for series, one answer for movie.
Just one.
Yeah. Oh, yeah. Favorite series.
I don't know. I'm currently watching Friends, so I guess that's my favorite series because I watched it many times. But I watch many series. And in terms of movies, maybe not a particular movie, but a particular director. His name is Lars von Trier, and he's from Denmark.
Okay.
So I like a lot of his movies.
Oh, well, does he make usually Danish movies or?
Yeah.
Okay. Anything that the listeners might know?
I mean, sometimes his movies can be controversial.
Oh, really? Okay.
Yeah, and he's not. I mean, he's been around for a while, so some of his movies are quite old, like 90s and things like that. Which movie from him can I mention? I forgot the names, but there's a very funny one which is called The Idiots.
Okay.
So yeah.
I recently watched a Danish movie, maybe like 2 years ago. It's about these people found out, it's like a comedy drama kind of thing. And they found out that there was this philosopher, back in the days that claimed that humans made out of like, I don't know, 30% alcohol or something.
Of course.
Is that the movie that was directed by him?
I think that's Thomas Vinterberg.
Someone else?
But that's a really good one.
Yeah, I really enjoyed that.
Yeah.
Yeah.
I mean, that can be a favorite movie.
Who's the main actor? The main actor is super famous.
I forgot
he's
the
a
names
Danish
now,
guy, but
he was on this movie, The Hunt, right?
Oh, I do recognize him from something, but
I should remember that.
Matt? Is it Matt something?
What was his name?
Danish guy.
Mads Mikkelsen.
It's Matt something, right?
Mads Mikkelsen.
Matt Nicholson, yeah.
Mikkelsen. With M.
Yeah. Okay, yeah. Such a good actor.
Yeah.
Such a good actor.
Yeah.
That was such a good movie too.
Yeah.
You should watch it. You should watch it. What was it called? Do you remember?
Another Drink.
Another Drink.
Yeah.
Oh, and the main song of it, it's like, what a life. What a beauty.
Yeah, it's a really good one. I
like,
watched it several times, so yeah.
Yeah, I love that movie. Do you usually listen to any podcasts at all?
Sometimes I'd listen to the ones from Lex Friedman.
Oh, yeah. Same. Oh, cheers.
Those ones are like 4 hours or something.
Yeah. Lex Friedman was one of the motivation and inspiration for my podcast.
Podcasts are really, really good.
Yeah. Actually,
I mean, he's with top people, not like ordinary people like me. But
right. But when I was preparing for this interview, because this was kind of my first technical interview, I was listening to his podcast to see how he communicates technical things, because he communicates with, like CEOs and like other researchers.
Yeah, all of the top people in
Yeah.
many fields.
Many
right?
fields.
Yeah,
And then but then I feel like at the same time he tries to, even in the research area that he's not fully expert in, like
Yeah.
for example, astrophysics and
Yeah.
things like that. And I was like, how does he ask questions and how
Yeah.
does he communicate, catering for people
Yeah.
that might not
Yeah.
be an expert in
Yeah.
themselves. So yeah, I was listening to that. Yeah, Lex Friedman, great guy.
That's easy to answer.
Maybe I will have him here one day. Favorite book?
That's a difficult question.
Yeah.
My favorite author, and this is difficult to say favorite, but he's the favorite still, is Dostoevsky.
Russian guy?
Yeah.
Yeah.
Novelist. Yeah.
I think one of Lex's favorite too.
Oh, really?
Yeah, I think so.
I
think
didn't
so.
know that.
I think he read it in both Russian and English.
Yeah.
Yeah.
I read in Spanish and English.
Right.
Not Russian.
Yeah, and I think one of Lex's favorite. This.
So, yeah, I cannot tell a favorite book because he has too many good ones.
True.
Maybe Brothers Karamazov is, yeah.
Okay.
It's probably the one that I like the most, but it's not too far away from ours.
What's your proudest accomplishment?
Can I have two?
Yeah, you can have two.
So one of them is the PhD,
Yeah.
and the second one is running marathons.
Nice. And that's a good segue because the next question is, you're into running.
Yep.
And you're also into cycling, right?
I used to do a little bit of cycling, but not
Okay.
anymore because I don't have enough time for the cycling because of the running.
Right. Oh, maybe this
So
answers
when
your-
I'm not doing running, I'm resting from the running. So I
Right.
cannot waste my time doing cycling.
Maybe the answer is this question then. Because the question was, if you had to choose between cycling and running, just to do for the rest of your life, and you can't do the other one, which one would it be?
Running, of course.
Running.
Which is the current thing, but I always think when I get some really serious injury from running, then I will move on to cycling. That's the plan.
But running, you enjoy more.
Yeah.
And this is such a cool coincidence because my next question, I've written it here too, is inspired by Lex Friedman. He quite often asks the guests what the meaning of life is.
Being happy.
Being happy. Damn.
Being happy without making other people unhappy. That's because some people try to be happy while hurting others, or sort of making others unhappy. So being happy while making other people happy as well. Yeah, that's a good. Yeah.
That's a perfect way to end it. Yeah, I couldn't have asked for a better ending. Well, thank you so much again.
Thank you.
And yeah, if you have any questions, then I'll put your links in the description. So yeah, thank you so much, and we're out of here.
Thank you. Thanks so much. Thank you.
Bye.